Now, let's discuss that the posterior distribution, which represents our updated belief, is proportional to the product of the prior distribution and the likelihood function. This means the posterior reflects both the initial beliefs encoded in the prior, and the information gained from the observed data, captured by the likelihood. Let's understand that the posterior distribution encapsulates all knowledge about the parameters after we've incorporated the data. Analyzing the posterior allows one to make inferences, predictions, and decisions based on the combined prior knowledge and observed evidence. Now, let's consider credible intervals, which define a range of values where the parameter is likely to fall with a specified probability. For instance, a 95% credible interval suggests there's a 95% chance that the true parameter value lies within that range, offering a measure of uncertainty. Now, let's explore the posterior predictive distribution, which provides the probability of observing new data, given the data already seen. This is useful for forecasting or assessing how well the model generalizes to unseen data. Now, let's discuss that the posterior distribution is the foundation for making optimal decisions. By considering the uncertainty in the parameter estimates, captured by the posterior, decision-makers can make choices that are robust and account for potential risks. Now, let's see that posterior predictive checks are a method to assess how well the model fits the data. Data simulation from the posterior predictive distribution, then comparison to the actual observed data, is performed. Significant discrepancies point to potential model inadequacies. Now, let's understand the sensitivity analysis, which evaluates how changes in the prior distribution or model assumptions affect the results. This is crucial for understanding the robustness of the conclusions. Let's explore that Bayesian model comparison techniques, such as Bayes factors, compare different models to choose the best one. This allows for selection of model that best balances fit and complexity.